Hello everyone, welcome back to your own mathematics channel asm.geniusjunction. I am Abhishek Sharma sir, your mathematics mentor. In today's video, we are going to cover 0606 Add Maths Unit 1 Functions. This is your video number 4. This video is in continuation with video number 1, 2, 3. So if you have not gone through with video number 1, 2, 3, I suggest to please go through with video number 1, 2 and 3 so that you can effectively understand the concepts discussed over here. The topics which are going to be covered in this video are modulus functions, operation on modulus functions, solving a modulus function, graph of a modulus function, and then we will discuss inverse functions, graph of inverse functions. Okay, so let's start without wasting time. Yes, so modulus functions. When we talk about modulus function, the first thing which we need to understand is that modulus functions are those functions which talks about magnitude only, right? For example, if I write down the definition of a modulus function, that I can say the modulus of a number is the magnitude of the number without a sign attached to it. Without a sign attached to it. What it means to say, I'll explain you. Let's say that suppose if I'm having a number -4, and if I put modulus sign represents two straight bars, these two vertical strokes represents modulus functions, right? This particular two straight vertical strokes represents modulus. Okay, this is just a representation packed in the box. Now suppose if I am talking about modulus of -4, then the final answer for it is going to be 4. And if I talk about the modulus of +4, again the answer is going to be 4. Modulus of a number, some of the times it is also referred as absolute value. Okay, the modulus of x, if I want to represent modulus of x, then it can be written as mod of x equals, I can say that it can be equal to plus x, it can be equals to 0, or it can be equals to minus x. It depends on the situation. Suppose if x is greater than 0, this can be when x is equals to 0, and this statement comes when x is less than 0. Okay, so let's start with the solution of these particular type of questions so that you can understand the concept in detail. So here we are taking few of the questions. This is your question number 1, which is based on this particular topic, where I am having a modulus function 2x plus 1, and on the right hand side we are having 5. Okay, so this is the modulus function. Whenever we solve a modulus function, we always use one property. So I'm writing down that property for you. Suppose if I'm having a modulus function ax so the modulus function ax plus b is equals to cx plus d. You can see that there is a modulus function on the left, and on the right there is a simple linear function, right? So whenever we will solve these types of equation in which there is one modulus function on the left and on the right you are having a linear function or a constant, in that case we will open this modulus function with plus cx plus d, and ax plus b gives you minus cx plus d. This is going to be your equation number 1, which is to be solved, and this one will give you equation number 2. Both the equations will be solved separately to get the final solutions. I will be using this property to solve the question which we have got right above. Okay, so let's solve our question number 1. So question number 1, 2x plus 1 mod gives you a constant 5. Using the property above, I can say that I will be getting 2x plus 1 equals to plus 5, and 2x plus 1 is equals to minus 5. Okay, so when we will solve this further, I will get 2x is equals to 5 minus 1, that is 2x is equals to 4, and this gives you x is equals to 2. This is one of the possible answer. Moving in the same way, I will get 2x is equals to minus 5 minus 1. This is going to give me 2x is equals to minus 6, and the final answer for this is minus 3. So now I have got two answers for the given question. Now I'm going to check whether the two answers satisfies the given equation or not. Let's move on to checking part. So we are checking the solutions which we are getting are actually the answers of the given equation or not. So I will put, right, LHS. I am going to use LHS, right? So LHS is mod of 2x plus 1, and I am talking when x is 2. So when x is kept equals to 2, I will write 2 times 2 plus 1. That gives me mod of 5, and modulus of 5 is actually 5. So therefore we can say that x is equals to 2 is the solution. Okay, now moving in the same way, we will talk when x is kept equals to minus 3. So when x is kept equals to minus 3, we will get 2 times minus 3 plus 1 mod. I will solve this further. I will get minus 6 plus 1. I will get minus 5, and modulus of minus 5 again gives me 5, which is RHS. So I will say yes, x is equals to minus 3 is the solution. So here we can see that we got two solutions for the given equation. This is your solution number 1, and this one is solution number 2 for the given equation. Okay, so both of them represents the solution for the given equation. This is a way we represent and solve a modulus function. Let's take few more examples. Please see that in this particular question we were having modulus function on the left, and on the right we were having a number, right? So let's take few more examples where we are having some complex situations. We are doing one more question based on the same concept of modulus. So we are having modulus function on the left, that is 2x square minus 3x, and on the right hand side this time we are having a linear function 4 minus x. Yes, so now how we are going to approach these types of questions? Again, we are going to use the same properties which we have discussed above. So I will be opening this particular question, 2x square minus 3x. I will remove this modulus sign from the left, and I will put a plus sign. This is going to give me my equation number 1. And in the same way, I will write 2x square minus 3x is equals to minus 4 minus x. This is going to be my equation number 2. I will be solving both the equations simultaneously. So let's move further. This is 2x square minus 3x gives me 4 minus x. Solving it, I will be getting 2x square minus 3x plus x minus 4 gives me 0. I am bringing all the terms on the left hand side, solving it to get the final equation. I will be getting 2x square minus 2x minus 4 gives you 0. We can use the concept of middle term splitting. First of all, I will take out 2 common, so I will get this. Okay, so now I need two numbers whose product is minus 2 and sum is minus 1. So I will be writing x square minus 2x plus x minus 2 is equals to 0. You can see these two numbers will give you product as minus 2x square, and their sum is going to give you minus x, right? So let's solve this further. I will take out x common. It is going to give me x minus 2 plus 1 common. I am again getting x minus 2. Two factors are common. So I will solve it like this. So I'm getting two answers. One is x is equals to 2 and the other one is x is equals to -1. So these are the two possible answers, right? In the same way, we are moving to other part of this equation. So let's solve the second part of it. Yeah, so solving the equation number 2, we are going to get 2x square minus 3x is equals to -4 plus x, right? We will bring everything on the left hand side, so I will get 2x square minus 3x minus x plus 4 gives you 0. Solving it, I will be getting 2x square minus 4x plus 4 is equals to 0. I will be taking out 2 common, so I will be getting x square minus 2x plus 2 is equals to 0. Yes, so solving this equation further, you can see that this particular equation is having two imaginary roots. So the two imaginary roots are going to be 2 plus minus 2 iota whole over 2. So we are going to ignore these two solutions, right? Because these are imaginary roots. So we will not solve this. So we are left with two solutions for this particular equation. So let's quickly check what we are getting is actually the answer or not. So I will be checking the two equations. My equation for the given question was 2x square minus 3x whole mod gives 4 minus x, right? So we need to check the solutions. So we are doing the checking part. Okay, so first of all, I will put x is equals to 2. So I will say LHS. When I will solve LHS, I am going to get 2 times 2 square minus 3 times 2. Solving it, I will be getting 8 minus 6. That gives me mod of 2, that is 2. So LHS is giving us 2. Okay, next let's talk about RHS. RHS is 4 minus x, and I will substitute x is equals to 2. So I will say that x is 2. Okay, so let's solve this. I will get 4 minus 2, that is 2. So we can say LHS and RHS are coming equals to each other. That means x is equals to 2 is the solution. In the same way, I'm going to check for x is equals to -1, right? So in the LHS, I will put 2 times -1 square minus 3 times -1. I will be getting mod of 2 plus 3, that gives us mod of 5, that is 5. This is your LHS. Let's talk about the RHS now. So I will say this is 4 minus -1, that is 4 plus 1, that gives you 5. So yes, I can say therefore x is equals to 2 and x is equals to -1 are the solutions for the given modulus function. Okay. Okay, so now I expect that you all understood how to solve a modulus function. Now we will move on to the next important topic of this particular video, which is based on the concept of graph of modulus function, how we need to construct the graph. Yes, so now our next topic is graph of modulus functions. So now we are going to learn how to plot the graph of a modulus function, right? And how we are going to use particular graph to find the solutions as well. So let's take one example. So I am taking one example to make you understand how to solve the graph, how to plot the graph of modulus function. So let's say that I am having a graph of y is equals to x over 2 minus 1, right? I have taken a simple equation of mod function and we need to sketch the graph of it, right? So question is sketch the graph of this modulus function, right? Okay, so first step is remove the modulus functions. So I will say that it is x over 2 minus 1, and now I'm going to plot the graph for y is equals to x over 2 minus 1. So I will be taking few points, right? So I will take first value of y as 0. So if I would take y is equals to 0, I will be getting 0 equals to x over 2 minus 1. That gives you x over 2 is equals to 1. This 1 will move on that side. So finally you will get x is equals to 2. So this working is not to be required to be shown, but we are getting x is equals to 2. Now I will put y is equals to x is equals to 0. So when I will put x is equals to 0, I will be getting y is equals to minus 1, right? So we have got 2 points. So let's take any random value. I will take 4. If I take x is equals to 4, so 4 by 2 is 2 and 2 minus 1 is 1. So here you can see that I am having 3 points which will be plotted on the graph. So let's take one graph and plot these points on the graph to get the answer. Yes, so now I am going to plot all these 3 points. So first of all, I will plot x-axis and y-axis. So let's take this as x-axis and this is your y-axis now. Okay, so we are having x-axis, we have y-axis. Let's quickly plot the points. This is your origin 0, 0. Okay, so first point is 2, 0. So this is your 2, 0. Next one is 0, minus 1. So 0, minus 1 is represented right over here. Okay, and the fourth point is going to be 4, 1. So this is your 4, 1. Okay, let's come on to the very important part now. Initially, when we were plotting the graph of this function, we have removed the modulus sign. But in actually, there are modulus signs. So we need to understand that y can never be negative. But here in second case, we are getting y as negative. So what we are going to do is, we will make this minus 1 to plus 1. Why? Because there is a modulus sign present over there, right? So y cannot be negative. So I will make this particular minus 1 to plus 1. And now this particular point on the graph is coming on this particular position now. Okay, so now we need to plot 3 points which are there on the graph. And when we will plot these 3 points, this is your graph for the given modulus function. Y equals to x by 2 minus 1 mod. Okay, so I will put 2 arrows. Okay, so this is a way we need to solve the graph for a modulus function, right? I hope you are able to understand how to plot the graph of a modulus function. Step number 1 is remove the modulus sign. Step number 2, make a box, right? In that box, you need to take the value of y is equals to 0 first. You will take the value of x is equals to 0 and then any other random point. And based on these 3 points, we will plot the graph. Y can never be negative. So obviously this particular negative sign will be removed. So it will become plus 1. So I have taken this value over here and then we have straight away plotted the graph for the given modulus function. Okay, so now we have understood how to plot the graph of a modulus function. So we are going to solve one more question based on the same concept. Yes, so now we are going to do one more question which is based on the same concept of modulus function and sketching the graph of modulus function. So let's take one question. The question is mod of 2x plus 4 is given equals to x plus 5, right? Question is solve the given mod function using graph. Okay, so now we need to solve this modulus function using the graph. We are going to proceed. Let's see this. So here we can say that there are 2 equations actually involved. This is y is equals to mod of 2x plus 4 and y is equals to x plus 5. So first of all, I will write down y is equals to 2x plus 4, and on the other side I am writing y is equals to x plus 5. This is my equation number 1 and this is my equation number 2. Okay, so now let's solve this. Again, I will remove this modular sign initially, so I will get y is equals to 2x plus 4, but I will keep in mind that y cannot be negative, so I am quickly making a box x and y. Okay, I will be in need of 3 values, so I am making a box in that way only. I will put y is equals to 0. When I will put y is equals to 0, I am going to get minus 4 over 2, that is going to give me minus 2, right? And when I will put x is equals to 0, I will get y is equals to 4. Okay, so now we need to take one more point, so I will take x is equals to minus 4. Okay, so when I take x is equals to minus 4, it is going to give me minus 8 plus 4, again minus 4. Okay, so in this way we are having 3 values right in front of us. We will plot the graph accordingly. We need to make sure that this particular value will become positive 4 when we will be doing it on the graph. Okay, in the same way we will solve the second equation which is there in front of us. So second equation is again a linear equation. Second equation is representing a linear equation, so it is very simple. We need only 2 points. We have done this many times before. I will put x is equals to 0 to get y is equals to 5. Then I will put y is equals to 0 to get x is equals to minus 5. Okay, so now we are going to plot the graph for the two functions. This is your modulus function and this is your equation of line, right? We need to plot both the graphs. Okay, so we will take the axis accordingly. So first of all, let's plot the axis on the graph. Since it is going to be above x-axis only, I am plotting x-axis very low in the graph because I know that this graph is going to be above x-axis always, right? And this, since there is an involvement of line as well, so line can be plotted on this graph easily. Let's mark the axis. This is your x-axis, x dash, y dash, and y-axis. Okay, so now this is your origin 0 comma 0. We need to plot few points. So this is first point is minus 2 comma 0. 2 points equals to 1 centimeter. So right, I will plot minus 2 comma 0. So let's say this is your minus 2 comma 0. This is going to be your point number 1. Next point is 0 comma 4. So this is going to be 2 and this one is 4. So we need to plot 0 comma 4. So yes, this is your 0 comma 4. Okay, so now next point is the minus 4 comma plus 4. I hope you are able to understand how it became plus 4. So I will plot minus 4 comma plus 4. So again, this is the point. Okay, this one is minus 4 comma 4. Now based on this particular information, I am going to plot the graph of it. So these are the lines for y is equals to mod of 2x plus 4. Okay, now we need to plot the graph for y is equals to x plus 5. That is your equation number 2. So we are having 0 comma 5 and minus 5 comma 0, 2 straight points. So quickly plot them. So I will plot 0 comma 5. So this is 1 point, right? This is representing 0 comma 5 and the other point is minus 5 comma 0. So minus 5 comma 0 lies over here. So this is minus 5 comma 0. Now I will straight away join these 2 points. So I will be getting our equation and I will stretch this line on both the sides so that I can come to know where this line is actually intersecting the other line. So here you can see easily that this particular line is intersecting the given modulus line at 2 points. This is your first solution and this one is second. This is your A and this is your B, right? So if we zoom in and try to understand, then we can easily figure out that the values of these points is -3 and the value of this particular point is 1. Okay, so -3 and +1 are the possible solutions. So let's quickly check them whether they are actually satisfying the given equation or not. It is 2x plus 4 equals to 2x plus 5. So I will write mod of 2x plus 4 is equals to x plus 5, and our possible solutions are x is equals to 3 comma y is equals to 1. Sorry, x is equals to 3 and 1. So I will quickly check whether these two values actually satisfies this or not. So I am just checking it. I will say when x is equals to -3, this left hand side becomes 2 times -3 plus 4 gives you -6 plus 4, that is -2, that gives you 2. And on the right hand side, if I put RHS, if I put x is equals to -3 plus 5, I will be getting 2 again. So yes, first part is the solution, right? Now let's talk about x is equals to 1 now. So in the RHS left hand side part, I will put x is equals to 1. So it will become 2 times 1 is 2, 2 plus 4 is 6, and mod of 6 is 6. And on the right hand side, I will be getting 1 plus 5, that is 6. So yes, both of them are solutions. So on graph, it was very clear, and we have algebraically checked both of them. This checking part is done to make sure that you are able to understand how we need to plot and how we need to show the solutions of the modulus functions, right? So yes, both of them are representing the solutions for the given equation. This is your answer, as well as this one is also your answer. I hope now you are able to understand how to solve a modulus function, how to plot the graph of a modulus function, how to solve an equation of a modulus function using the graph, right? So let's proceed further on the next part. Now we're going to understand next very important topic of this video, and the next topic for this particular video is inverse functions, right? So we will be talking about this inverse functions, how these functions works, how they are made, right? Okay, to understand the concept in detail, let's take one input value set and let's take one output value set. Okay, so these are two input and output value set connected by each other using a function. So let's say this is our f of x equals to x plus 1. Okay, now suppose if I say that the input value is 2, so output value is going to become 2 plus 1, that is 3. If I write the input value as 4, you will say the output value is going to be 4 plus 1, that is 5. If I say the input value is 11, the output value is going to become 12, right? So what f of x has done, it has increased the value of x by 1. Now if I talk about something which is doing the reverse of this particular function, okay, I am talking about a function which is going to reverse this particular process, then that particular function will be represented as f inverse x. And very easily you can say that what you are going to do to get the values back to 2, 4, 11, so you will say that you will subtract 1 from each value, right? You will subtract 1 from all these values to get these final values. So when you will put 3 in this, you will get 3 minus 1, that is 2. So you will get the 2 as it is. You will put x is equals to 5 in it. You will get 5 minus 1, that is 4. So yes, you are getting this value again. When you will substitute x is equals to 12, so 12 minus 1 will give you 11, and this again giving you the same value, right? So we can say that this function is actually reversing what this particular function has done. So that's the reason this particular function is represented by inverse sign. Yes, so you will be able to understand the definition, which says that the inverse of a function f of x is the function that undoes what f of x has done. So whatever f of x has done, this inverse function is actually reversing that. Now we are able to understand what is actually meant by an inverse function. Let's understand this concept by doing few questions. Okay, so now let's take one very simple example. So I'm writing this is your question number 1 on that same topic. I'm taking y is equals to f of x, that is actually equals to root of x plus 1 minus 5, right? And x is always going to be greater than or equals to minus 1. Okay, in this particular question we need to solve two parts of it. First says that find f inverse x, and second part says that solve f inverse x equals to f of 35. Okay, so these are the two values which we need to solve. So let's solve them quickly. First step, let's try to understand how to figure out the inverse of a function. So this is a function which is given to you. Write it over here. I'm doing the solution of it. This is y is equals to f of x, which is given to me equals to root of x plus 1 minus 5. Okay, so your step number 1 is write the function in the form of y is equals to fx. So this is y equals to root x plus 1 minus 5, right? This is going to be your step number 1. Step number 2 says interchange the variables. Interchange the variables. What I meant by saying this, I will interchange where there is y, I will write x, and where there is x, I will write y. Okay, this is your step number 2. Now your step number 3, which says that solve for y. Solve for y means make y subject again. So when I will try to make the y subject again, I will bring this minus 5 on the left hand side. So I will get root y plus 1 is equals to x plus 5. In the next step, I will square on both the sides. So I will get y plus 1 equals to x plus 5 whole square. When I will solve this again, I will be getting y equals to x plus 5 whole square minus 1, right? So I have solved for y, and now I will write it in a very simplified way. This is my y is equals to f inverse x is equals to x plus 5 whole square minus 1. So we can say that this is your inverse function. Okay, so now I hope you are able to understand how to make an inverse of a function. We are moving on to part B, solution. So in this particular part we need to solve f inverse x is equals to f of 35. Okay, so now this is your equation which we need to solve. Okay, so what I'm going to do is, first of all, I will calculate f of 35, right? So my equation f of x, I'm writing it over here again. So this is root of x plus 1 minus 5. Okay, so I will put 35 in it. So I will get root of 35 plus 1 minus 5, that gives me root of 36. this is root of 36 minus 5, that is going to give me 6 minus 5, that is 1. Okay, so now we are having f of 35 as 1. So I will equate this particular value with f inverse x. So I will write f inverse x is actually equals to 1. So let's solve this now. This is my x plus 5 whole square minus 1 is equals to 1. Okay, now let's solve this. I'm getting x plus 5 whole square is equals to 2 now. If I will solve this further, I will get x plus 5 is equals to plus minus root 2. Okay, so now I am getting my final answers as x plus 5 is equals to plus root 2 and x plus 5 is equals to minus root 2. If I solve this, I am going to get two answers. One is minus 5 plus root 2 and the other one is going to be minus 5 minus root 2. So now we need to understand that the range of f of x, is always greater than or equals to minus 5. So domain of f inverse x becomes greater than or equals to minus 5, right? So the only solution, hence the only solution of f inverse x is actually equals to minus 5 plus root 2, right? So this is the final answer for the given question. Okay, so now I expect that you are able to understand the concept of inverse function, how to find out the inverse function and how to solve questions based on inverse functions. Yes, so now we have reached on next very important topic, that is graph of inverse functions. And trust me, this one is going to be very simple topic, graph of inverse functions, right? How we need to solve the graph of inverse functions, very simple. So I am taking straight away one example to make you people understand it quickly, right? So I am taking a simple example, that is f of x equals to x minus 2 whole square, and the domain is given as x is less than 5, less than equals to 5 and greater than equals to 2. Before starting with the graph of inverse function, we need to understand few of the basic important criterias for the inverse function, right? So inverse of a function, right, which we have done before, inverse of a function is always possible. Inverse of a function is possible only if the given function f of x is a 1-1 function, right? We have taken an example in the same way. So our function is going to remain 1-1 function. Okay, so function is okay. Before starting with the solution of a graph of inverse function, let's understand one very important thing. In the mapping diagram, we have gone through with three types of mapping, right? In the first type of mapping, you must have remembered that the one input value was having one output value, right? This was your 1-1 mapping. In the second case, this was your case 1. This was your case 1. In the second case, we were having, this was your input values, and for two input values we were having the same output value, right? This one was your many one mapping, right? This was your second example. And your third case was when we were having an inverse function, when we were having the set of input values and the set of output values, and one input value was connected to two output values. This is your one to many mapping, right? So out of all these cases, only one mapping is the mapping which has inverse function possible, right? So you need to remember this thing, that inverse of a function is possible only if this is the case, not for this, not for this, right? Okay. And of course, if you go through with this particular mapping diagram very effectively, then you will be able to see this particular function f of x. So for the function f of x, this is your domain and this is your range. And in the same way, if I write down f inverse x, so for f inverse x, this one is going to be your domain and this one is going to be your range, right? I am writing this particular thing again just below this, so I can easily say that range of f of x is actually equal to domain of f inverse x. This is your point number 1. And point number 2, the domain of f of x is actually equals to range of f inverse x. So very simple language we need to understand. Whatever is the domain of f of x is actually going to be the range of f inverse, and the range of f of x is going to be the domain for f inverse. Okay, so now keeping these things in mind, that these are the 2 points and function is required to be 1 1. Now based on this particular information, we are going to understand the graph of inverse function f of x is equals to x minus 2 whole square, right? So now let's take this particular case in which we are having a function f of x is equals to x minus 2 whole square, and the input values are given as 2 to 5, right? So let's quickly make a graph of it first of all. Okay, so now we are having a graph in front of us and we are going to plot the graph of f of x is equals to x minus 2. So let's quickly make axis on the graph. So this one is your y-axis and let's say this is your x-axis. Okay, and now mark them. This is your x-axis, this one is your y-axis. Let's mark this as y dash, this is your x dash, this is your origin 0 0. Now I am having few points, so this is going to be 2 0. I will be taking this as 1 2 3 4 5 6 7 8 9 10. Okay, in the same way I am going to plot the graph for this. This is 1 2 3 4 5 6 7 8 9 10. Okay. Yes, so now we are going to plot the graph for the given function. So this is going to be your 2 0. Your next point is 3 1. Your next important point is 4 4. So this is your 4 4, and then we need to take 5 9 as well, right? We need to take one more point, that is x is equals to 5 will give you y is equals to 9, right? Because domain is given to you from 2 to 5, so we need to take the values from 2 to 5, so it is going to represent 9. So 9 is Yes, here it is. Now I'm going to plot the graph for the given function. So this is your graph passing through the required points. Yes, so this is your graph passing through the given points, and I will remove the graph which is above 9, because 9 is the maximum possible value which this graph can attain, right? It cannot move beyond 9, right? Because domain is already given to us from 2 to 5. Now we will plot y is equals to x line. I will explain you why I'm plotting this. So this is your y is equals to x line. Okay, now we need to understand very important criteria, that f inverse x graph is actually the reflection of f of x graph in y is equals to x line. Because if you remember that when we were calculating inverse function, we have interchanged the value of x and y, right? So we need to reflect this pink color curve in this y is equals to x line, right? So I'm taking the points to make you people understand how we are going to do this. So this point is going to remain here only. This is 2 comma 1, 2 comma 0, so it is going to become 0 comma 2, and 0 comma 2, this is 4 comma 4, and this last point is actually 5 comma 9, so it will become 9 comma 5, so it will be represented over here. Okay, now these 3 points will be connected. Yes, now you can see that the black color curve is actually representing the inverse function f of x on the graph. So now we have understood that suppose if you are having a function f of x, you are having a domain of it. So first of all, we will quickly plot the graph of it. Then we will make a line y is equals to x, and we need to reflect this pink y is equals to x curve in the y is equals to x line. And after plotting all the points, we have plotted the black color curve. This black color curve is representing f inverse x, right? So inverse function graph is always the reflection of f of x graph in the y is equals to x line. Okay, so this is very simple, and this is very easy to make the graph of inverse of a function, right? I hope you are able to understand all the concepts for unit number 1 of 0606 ADD which were covered in all the 4 videos. Go through all the videos effectively so that you can understand the concepts in detail, right? We will do one more video of advanced in which we will be having the questions from the past year papers to understand the things in a more elaborative way. But before that, I request you all to kindly go through with all the 4 videos effectively, practice them, plot the graphs by your own hands so that you can have learnings. Thank you so much for watching the video. Have a good day.